Hi everyone, so hope you're all doing well. And if you're new to the channel, this channel is called A-Level Maths Tutor UK. So as the name of my channel suggests, I'm an A-Level Maths tutor. But in today's video, I wanted to go through 6 shocks of a maths degree. So some of you guys watching this may be thinking about doing a maths degree, or maybe some of you watching this are literally going to do a maths degree in September. So this video is really for you. So this is 6 shocks that I personally found when I started my maths degree, and 6 shocks that I think a lot of people find when they start a maths degree compared with A-level maths and further maths, for example. So yeah, I'm going to go through 6 points that I think you guys should bear in mind before you do potentially start your maths degree. So the first thing that I'm going to say, the first shock, is that you have to learn so many definitions in the maths degree. So, in A-level maths, for example, a lot of the time you're doing exercises in class. So you're sat in your classroom, your teacher's going through going through the material that you need to learn. And then, the teacher goes through some examples, and then you've got time in class to practice examples, maybe some textbook questions, and you get lots and lots of practice time in class, going through, any new theory or any new definitions that you learn. But the thing is that at university, because you're sat in a lecture theatre, especially in first year, you're sat in a lecture theatre with 200 to 300 people, the way that you learn maths is very different. So the way that you learn maths at university is you learn maths through a lecturer standing at the front of your lecture theatre, basically copying out his or her lecture notes. That's kind of how it works. And in those lecture notes and in your courses that you'll do within your maths degree, you'll have so many new definitions to learn. So you'll have to learn the definition of a function. You have to learn the definition of an injective function, of a surjective function. You have to learn the definition of a convergent sequence. You have to learn the definition of a convergent sequence of functions. You have to learn the definition of a continuous function. You have to learn the definition of a random variable. You have to learn the definition of a discrete random variable, continuous random variable. So you may like hear the words that I just said there, or the terms I was just saying there, think, oh, I know the definitions of those. We did those all in A-level maths. But the thing is, you don't know the proper mathematical definitions, and the definitions that you're taught in a maths degree are very technical and they're very mathematical. So you will come across, especially when you do a module, you'll probably do an analysis module or a real analysis module in your first year. You'll see a lot of definitions, some really technical definitions where you have what's called epsilon delta definitions. I don't expect you guys watching this to know what I'm on about now, but you'll see what I mean when you get there. That the definitions are very precise, they're very mathematical, very technical. There's no numbers, it's all letters and Greek letters, and you'll see what I mean. So there's a lot of definitions you have to understand, and a lot of very technical abstract definitions as well, which are very difficult to process in your, difficult to visualize, is what I'm trying to say. And that's actually one of the points I'm going to come on to later in this video as well. But the first key shock is you're going to have to learn a lot of definitions in your revision. So a lot of your work in term time and in revision time will be making sure you know your definitions inside out. So that's really, really key. And not just, a vague definition, proper, precise, rigorous mathematical definition. So that's something that you've got to bear in mind for a maths degree. Now, the second shock that students will face in a maths degree is that there is a lot of proof, especially in pure maths. I mean, pure maths literally at university is literally just proof. There is a lot of proof, especially, as I said, in pure maths. In applied maths as well, in your first year, you'll be doing a lot of proofs. I mean, in second and third year, especially if you do more applied maths kind of stuff, there are proofs. Like in every maths module you do, there will be proofs, but it's kind of, the proofs become a lot less heavy in the applied stuff. So in the applied modules that you do, and when you do those exams in those applied modules, you won't have to do a lot of proof, a lot of, very pure proof. But in your pure modules and in your pure module exams, you'll be doing a lot of proof, a lot of proving very difficult results. So, don't think there's, in a maths degree, you're going to avoid proof, because a lot of the maths degree is going to be proving. So if you enjoyed proof at A-level maths, then a maths degree really would be for you. So if you didn't enjoy proof in A-level maths, then maybe a maths degree may not be for you. I'm not saying it's not for you, but I'm just saying if you really hated proof in A-level maths, you hated, proof by contradiction and all that kind of stuff, you really were like, oh no, I really hated that. Maybe maybe have another little think whether you want to do a maths degree, because you could do, there's so many degrees you could do. You could do physics, engineering, computer science. So just if you want to do a maths degree, a maths degree is a great degree to choose, and I don't regret choosing a maths degree at all. But do bear in mind that if you're not a fan of proof and you're thinking, should I do a maths degree, just bear that in mind. But if you do like your proof, the great news is you're going to be doing lots and lots of proof in a maths degree. So that's good news for you guys. Now, another third kind of shock is that in A-level maths, obviously you study differentiation, you study integration, you study some differential equations as well, and that's pure maths. So in A-level maths, they call that pure maths. So differentiation and integration and solving differential equations, generally speaking at university, that's kind of under the applied maths bracket. So generally, calculus, differential equations, you would call that applied maths at university. Now, obviously, like calculus and differential equations, technically speaking, it is pure maths because it's maths for the sake of maths. And if you do, you probably, depending on your university, you probably will have modules, pure modules in differential equations, but they're going to be very proof heavy. So in pure maths differential equation modules at university, you won't really be solving differential equations, but you'll be doing proofs about differential equations, proofs about whether solutions to differential equations exist or whether they don't exist, proofs about, methods to solve differential equations. Whereas in applied differential equations modules, you'll be solving them. So the kind of maths that you did in A-level maths, or you're doing right now in A-level maths, where you're solving equations, you're doing integration, you're calculating integrals, you're calculating derivatives, you're doing all your differentiation, you would call that applied maths at university. Now, the theory behind differentiation and integration, again, that's pure maths, so that's still pure maths. So like the theory behind where integration comes from, and you'll study that in your first year. You'll study some differentiation and like the theory behind differentiation and integration in your first year in your analysis course, or some universities call it real analysis. And you could probably, and again, if you really like your pure maths and your proofs, you can choose more modules in second and third year, such as metric spaces, integration, measure theory, which are all very theoretical calculus modules and theoretical calculus topics. But they're not. Those are pure topics. So those are measure theory, integration, the theory behind integration. That is very, very pure because you'll be doing lots and lots of proof. But the integration that you saw in A-level maths, you would call that applied maths at university. So hopefully that kind of made a bit of sense. So yeah, that probably sounded a bit confusing. So I was talking about topics you've not probably heard of before. But yeah, just be aware that the calculus that you were doing in A-level maths, your lecturers would probably call that applied maths at university. And it's called and it would be applied maths because really the whole reason why you do differentiation, integration, and all this kind of stuff is really for the sciences. So you really use it to apply physics, chemistry, biology. That's where these things are used in real life. So you'll be solving differential equations, you'll be doing your calculus, your integration, but with real life problems. So that's why it's kind of under the applied maths bracket rather than the pure maths. But of course, as I was just saying, the theory behind where integration comes from, that's pure maths. So the proofs behind that, all the rigorous, tough proofs, that's pure maths. But actual doing integrals, you would call that applied maths. Now, the fourth shock is that the style of lectures are very repetitive. So what you'll see in a lot of your modules is, especially in your lecture notes, is you have a very similar format throughout every single one of your modules lecture notes. So normally what you'll get is you'll get a definition, and then you'll get like a proposition, and then or maybe a theorem, and then you'll get a proof. I mean, I'll show you on the next slide what I mean. So your lecture notes may look something like this. Obviously, imagine you've got your notes, your A4 piece of notes that you're given to the start of your course. So they may look something like this. So a page may look like definition 1.1. A geometric random variable is ... So this is your definition that you'll be given, and then after that you may be given a proposition. So proposition 1.1, the mean of a geometric random variable is 1 over p. And then underneath that in your lecture notes, you get a proof section. So normally what a lot of lecturers do is that they'll leave the proof section blank, and then they'll show you the proof in the lecture. So they'll actually write on the whiteboard or the blackboard, they'll write the proof of how you prove that the mean of a geometric random variable is 1 over p. And that kind of definition, proposition, theorem, proof, definition, proposition, theorem, proof. It's very, very repetitive throughout the entire set of your lecture notes for all of your modules. So it does become very repetitive. So do bear that in mind, do bear that in mind that the way you're going to learn maths at university, it will be quite repetitive. Now, when you get used to it, it's fine. And you can actually get into this state of mind where you kind of enjoy this repetitive learning, where you learn a new definition, you get a proposition, and then you prove it. You learn a new definition, you get a proposition or a theorem, and you prove it. It can become a quite enjoyable, especially if you like repetitive, learning, and you like to, repeat the same process over and over again. But some people may find it quite dry and quite bland, and not very engaging. So again, just be aware of that in a maths degree, that the style of learning, style of your lecture notes, the style in which you're taught the new material can be very repetitive. So you might enjoy that, or you may not enjoy that. Now, the fifth shock, and this is quite a positive shock, is that obviously maths is a huge subject. Well, I say obviously, but you'll find out if you do a maths degree how wide and broad the subject is. So, obviously applied maths, pure maths, even, the subject of pure maths, the subject of applied maths, these are huge areas of study, and a maths degree really does open so many doors. So even if you do a maths bachelor's degree, you can still do, a master's degree in physics or finance or engineering or, quantum physics. You've still got so many doors open for you, computer science as well. And I just list here some potential modules that you may get, at your university. So quantum physics, quantum mechanics is a very popular module that people do. Number theory, mathematical biology, fluid mechanics. So the mechanics of how gases and liquids move. Mathematical philosophy. So, that's quite an interesting thing to think about as well. Set theory, the theory behind sets. Group theory, so you'll learn in your first year, you've definitely learned group theory in your first year. You'll learn about what a mathematical group is. Financial mathematics, if you're interested in going to finance, probability theory, financial mathematics, maybe something that you're interested in. General relativity, special relativity, so a lot of maths degrees offer modules in that kind of thing. So again, if you really like your physics and you're unsure whether whether to choose maths or physics, don't regret your choice of doing maths if you do choose maths, because you can actually do physics modules in a maths degree. Other modules, probability theory. So probability theory, again, is a massive field. It's a massive field. So it's not just calculating probabilities and Venn diagrams. It's huge. You've got Markov chains, you've got martingale theory, you've got obviously statistical theory, probability involved with statistics. It's a massive field. Financial probability, again, really massive field of study. Statistics, again, huge field of study. You can study, the theory behind mathematical statistics. You can study something called Bayesian statistics, which is a different way of thinking about statistics and a different way of thinking about hypothesis testing. So again, with statistics, you'll be doing lots of hypothesis testing, but different methods of hypothesis testing, and hypothesis testing for different things. So not just, hypothesis testing for the mean of a normal distribution, but also, the standard deviation, that kind of thing. So doing a hypothesis test for the standard deviation, hypothesis testing for different distributions. So, new distributions that you've not seen before. So, for example, chi-square distributions. So statistics is, again, a massive, huge, broad field of study. So yeah, you've got that as well. Discrete maths, and some people call it decision maths. So in A level, if you do further maths, you might have done some decision maths. So that kind of thing, algorithms, mathematical computing. So if you're into like computer science, again, you've got that involved in the maths degree. Information theory, which is kind of about the mathematical theory behind information. So information, in our devices, computers, phones, and also the information in particles, that kind of thing as well. So all of these are very, very broad field to study within the subject of maths. So maths opens up, a maths degree really does open up a lot of doors, and you have lots and lots of options of study in your second and third years of your course. So that's a good advantage of a maths degree. But the last kind of shot that I'm going to mention is that maths, especially pure maths, can get very abstract. So if you're a visual learner who likes to visualize things, so if you like, for example, mechanics, where you can visualize your forces on your force diagram. You may find pure maths very, very difficult at university because, you know, you'll be learning things such as, you know, groups. So you'll be learning group theory. What is a mathematical group? You'll be learning about rings. So what is a mathematical ring? And it's not, and when I say mathematical ring, I don't just mean like a you know, donut shape like that. I'm talking about something called an abstract mathematical ring, or a field. So if you well, you'll definitely learn about fields in your first year, because it's one of the key components of linear algebra, which is like a key first year university course module that you'll do. Again, you can't really visualize what a field is. You can't really visualize what a group is. You can't really visualize what a ring is. You know, these are very abstract topics. Vector space as well. I mean, vector spaces you can kind of visualize ish, but still, you know, when you're talking about vector spaces of functions, again, you can't really visualize that. So it's not like physics where, you know, you can visualize it because, you know, you can see physics with your own two eyes. You know, you can't see what a field is. You can't see what a ring is. You can't see what a group is. You can't see what a vector space is. It's a vector space of functions, for example. You know, you can't really visualize what that looks like. So if you are a visual person who needs to visually see how things work, you may find pure maths quite tricky, because you really do need to think outside the box a little bit with pure maths at university. And that's why I didn't really like pure maths at university. I was much more of an applied guy, because I do like, you know, I like doing my calculations. I like visualizing things. I like doing applied problems. But the pure maths is very, very theoretical, very abstract. It's very the thing is that the more pure maths you do, you'll see that actually pure maths is really, really, you know, it's applied a lot in the real world, but especially in your first and second year, maybe your third year as well, it'll be very dry pure maths, and it'll be very theoretical and lots of proofs, very hard proofs, and proving results and visualizing things that you can't even visualize in your head. So be aware of that. The pure maths can get very abstract, and that's why, you know, group theory, ring theory, it's called abstract algebra, because it's abstract. You can't visualize how these things work. So again, be aware of that. So if you do like, you know, if you do like problem solving and proofs and, you know, that kind of thing, then you may really love pure maths. But if you struggle with your visual side of things, you may not really like pure maths. And I didn't like pure maths. But that's still fine, because you can choose lots of applied maths modules. Obviously, look, you've got to do pure maths in your first year. Everyone has to do the same things in your first year. Everyone's got to do pure and applied in first year. But second and third year, you can really specialize. You can kind of just forget about pure maths. So that's the good thing about having a maths degree, is that you've got so many different options, you know, you can choose from. And, you know, I've listed some examples here, but you're going to have so many more different options as well. So don't just think, you know, maths at university is pure maths, 100% pure maths, because it's not 100%. You can do applied stuff as well. And if you are struggling, especially with the pure maths stuff in your first year, don't get bogged down by that. Try and get through your first year, because in your second and third year, it does get better, because again, you've got so many options you can choose from. So you can really specialize in the topics and modules that you really enjoy the most. So that's what I would say about a maths degree. So those are kind of 6 shocks that I personally found in my maths degree. So yeah, hopefully this video gives you like some insight into, you know, what a maths degree may look like, and what again, what kind of shocks you may face from a maths degree. So if you do have any questions, drop a comment in the comment section, and I'll try my best to answer your questions. So thank you very much for watching, and have a great summer.